Hello, everyone. My name is Jing Yu. I'm the CEO of Fortress Power. As you know, battery storage is one of the greatest inventions of humankind. Transitioning from lead acids to lithium is another huge milestone. Now, today I'm here to explain you how to calculate energy cost of different batteries, chemistries, and why now over 90% newly installed global energy storage are paired with lithium batteries. Our engineers have studied 6 different battery chemistry, including Fortress lithium iron phosphate chemistry. Now, if any of you do not know the difference between different lithium battery chemistries, we do have also a webinar. You're welcome to join us. Now, the first thing that we're looking to is round trip efficiency. Among all the 6 battery chemistries we have, lithium iron phosphate has the best round trip efficiency, as high as 98%. What does that mean? That means if you store 10 kilowatt hour in a battery, you can get 9.8 kilowatt hour out. That's very good. And if you look the lithium ion or lithium polymer, they are slightly less. Now, if you look into the flat lead acids and AGM, they are substantially less, somewhere between 10 to 18%. Nickel ion has the worst, as low as 65%. That also means in order to get the same amount of usable power, you will need to increase your PV array or your windmill size, and that means much more money. The second things that we started is our cycle lives. So as you know, each battery has its suggested double discharge setting. And what is double discharge? It's basically, for example, if you set up at 80%, you add a battery from 100% to be discharged to 20%, and then you charge it back to 100%. That means one cycle, and that means you set up double discharge at 80%. So you keep 20% remaining there. The lithium iron phosphate battery that we offer, we guarantee 6,000 cycles at 80% DOD. Besides nickel ion has 8,000 cycles, the other chemistries you can see they are much less, especially flat lead acids, AGM. If you discharge 80% every time, you only get somewhere between 300 to 500. If you use one cycle per day, which is pretty often for off-grid systems, self-supply, and time of use applications, with a lithium iron phosphate, you can get 16, 17 years. While other ones are less, the nickel ion is very good. You can get almost to 22 years. But again, if you look into the cost, you're gonna see that it's much expensive option and also very bulky. So it's more preferred by the utility company than individual or businesses. Before we calculate the cost per kilowatt hour, the energy cost, we need to calculate the total energy throughput of each battery chemistry. So here we take the 10 kilowatt hour battery as example, equal to 200 amp hour battery. What is total energy throughput? It's basically amount of energy a battery can be expected to store and deliver over its lifespan. Now, how does this number come? The energy throughput is equal to nominal capacity multiplying double discharge, multiply efficiency, and multiply cycle life. For example, with a Fortress LFP10, the nominal capacity is 10 kilowatt hour. You multiply 80% of double discharge, because again, we not discharge the battery in full if you One, you can, but we suggest you put, keep the 20% remaining capacity. Multiply efficiency, which is 98%, and multiply 6,000 cycles. Then you will get a total energy throughput of 1 LFP10 at 47 megawatt hour. Then you use the out-of-pocket cost for a homeowner. In this case, it's around 6,900. To divide it, the 47 megawatt hour, you will get a number of 14 cents per kilowatt hour. And compared to other batteries, the nickel ion is pretty close at 19 cents. The lithium ion and lithium polymer, they are about twice as much. The flat lead acids, AGM, they are 3-4 times more. So now you know that the lithium iron phosphate may cost you more upfront, but the over lifespan is going to save you a lot of money. Also, for the safety perspective, the lithium iron phosphate and nickel iron are very safe. The lithium ion, lithium polymer, flat lead acids, AGM, they all have a potential risk. Either, have thermal runaway or fire catching or release the harmful gas. Now, if you go with the flat lead acids and the nickel iron, you will need to go back to maintain the batteries almost every 6 months. And of course, not everyone has that desire to go back to maintain the battery every 6 months. So here is a quick comparison of 6 different battery chemistries. If you have any question, feel free to contact us. Or go to our website, www.fortresspower.com. You will find our phone number and email. Thank you so much.